Let me tell you a story before we start talking about the history of game. When I was in lower 6th or the 12th grade in high school, I studied computer science. One of my assignments was to write a tic-tac-toe game. I spent 3 months on it. When I was preparing this lecture, I learned that the first software that managed to master a game was programmed by A.S. Douglas in 1952 on a digital version of the tic-tac-toe game, and it is part of his doctoral dissertation at Cambridge. That means my high school teacher actually earned me a doctoral degree. It took about 4 decades to develop AI that are good enough to beat humans in classical board games. A milestone in AI research in games is the backgammon software named TD-Gammon, which was developed by Joe Tesoro in 1992. TD-Gammon employs an artificial neural network, which is trained by playing backgammon against itself a few million times. TD-Gammon managed to play backgammon at a level of top human backgammon player. The interest in using AI to play games developed because the ability to play certain games well was thought to indicate intelligence. In particular, there was a focus on games checkers and chess, as they have challenged humanity for hundreds of years. In the 1950s, we saw the start of a ballooning interest in developing AI for these games. After over 3 decades of research on tree search, in 1994, the China checkers player managed to beat the world checkers champion Marianne Tinsley. The game was eventually solved in 2007. What does it mean by a game is being solved? That means the outcome of a game can be predicted correctly from any position, assuming both players played perfectly. The software that first exhibits superhuman chess capability, IBM's Deep Blue, consists of a minimax algorithm. I will introduce minimax algorithm in another video. Deep Blue famously won against the reigning grandmaster of chess, Garry Kasparov, in a much publicized event back in 1997. 20 years later, it is possible to download public domain software that will play better than any human player when running on a regular laptop. So how difficult is it to solve a chess game? One consideration of game complexity is the branching factor. The branching factor tells us the number of decisions that we can take at any decision point. In the case of chess, the average branching factor is about 35. After Deep Blue's IBM's next success story was Watson, a software system capable of answering questions just in natural language. In 2011, IBM Watson competed on the Jeopardy TV game and won $1 million against former winners of the game. Soon after China and Deep Blue, the game of Go became the new benchmark for game playing AI with a branching factor that approximates 250 and a vast search space many times larger than that of chess. In 2016, Lee Sandel, a 9-dan professional Go player, lost a 5-game match against Google DeepMind's AlphaGo software. In 2017, AlphaGo won a 3-game Go match against the world's #1 ranking player Ke, running on a single computer. So what about AI in video games? While video games back in the 1980s were introduced as a niche activities for those having access to a video arcade or to consoles such as Atari 2600, they gradually turned into a multi-billion industry generating, in the 2010s, a global market revenue higher than any other form of creative industry, including film and music. In 2017, games generate a worldwide total of almost 100 billion in revenue, which is expected to rise to approximately $120 billion by 2019. A notable milestone in video game AI playing was reached in 2014 when algorithms developed by Google DeepMind learned to play several games from the classic Atari 2600 video game console on a superhuman skill level, just from the raw pixel inputs. One of the Atari games that proved to be hard to play well was Miss Pac-Man. The game was practically solved in June 2017 by the Microsoft Maluba team. Relatively recently, AI has also begun to be used to analyze games and model players of games. Game developers need to create games that can appeal to diverse audiences, and increasingly relevant as most games now benefit from internet connectivity and can phone home to the developer's servers. Facebook games such as FarmVille were among the first to benefit from continuous data collection, AI support analysis of data, and semi-automated adaptation of the game. AI may be able to play the role of a design assistant, a data analyst, a play tester, a game critic, or even a game director. So we covered some history of the development of AI in games, and some of the methods that have successfully defeated humans. Checkers, chess, Jeopardy, Go, and arcade games mark a historical chase of core major milestones for machine learning, tree search, knowledge representation and reasoning, and NLP. In turn, they result in major breakthroughs for AI.